space. So let's go back. So I think that intuitively, liquids and gases are both fluids of a different sort. So what is it that makes them both fluids even though they behave differently? So let's try and put a definition or like some bounds on what we mean by what a fluid is. Well, I mean, the obvious thing is it doesn't behave like that other state of matter, solids. So what is it that, like, in order to think about what kind of properties we're interested in about fluids, let's think about what a solid is. A fluid is not a solid, and what do we mean by that? Like, what defines a solid? Well, I mean, you guys have taken a course on solid mechanics, so you know some things about solids that are a little bit, I would say, more technical in detail than like the average person knows. So the thing about solids is that solids are more or less rigid, right? Like, you press on them, they don't really seem to deform very much, but they do deform a little bit. And that's actually, that little bit is actually a really important thing to understand because it'll help motivate our thinking about what a fluid is. So a solid is actually deformable, but it's deformable in a certain way. When you apply a force to it, it does deform, but it basically stops deforming at some point and responds elastically. So you can pull on a rod or something like that, and it'll deform, it'll move. It'll stretch, but the key thing about a solid is that when you release it, it goes back. It responds to deformation by resulting. It's sort of backwards of the way I normally think about it. So normally I think about pulling on something, so you apply force and it stretches. But of course, the way you probably learned about it in solid mechanics is a little bit different. So if I stretch it, so if I apply strain to it, that induces a, let's say, internal stress, right? So strain leads to stress, or usually I think about it the flip side of that. So stress leads to strain. What do we mean by strain? So strain is like how much two adjacent, so if I have two adjacent points in a solid and I stretch them, they move apart from one another. So that would be like a delta U. So that's like the displacement field, after, before, the difference between where a particle is before and after I do something. Well, I'll call that U. So the difference in that for two adjacent points divided by the initial distance between them would be called the strain. So basically in solid mechanics, it turns out that the stress is proportional to the strain, or the gradient in, so that's, if you think about this is actually the gradient in the displacement field. I'm not sure if it was presented to you that way at the time. Similarly, there are other ways that you can apply forces to a solid particle. So recall that if I have a chunk and I apply a shear stress to it, that actually causes basically a shear deformation, meaning that like the solid molecule will deform in a way that actually changes sort of the angular orientation of like an infinitesimal element. And the relationship between that, the change in angle of the element and the shear stress that was applied is called the shear modulus. All right, so now let's compare that to how a fluid responds to stress.